So thanks for the opportunity for this presentation. So I would like to introduce about this project to give you a little bit background information. So as you all may already know that the first district cooling plant in Kai Tak was built around 10 years ago. And this project is actually the last one in Kai Tak. So after this one, we are sure to have enough cooling cap for the whole Kai Tak. So what's so special about this project? So first of all, we are actually the biggest DCS plant in Hong Kong and also in Kai Tak in terms of cooling capacity. And we will use seawater cooling instead of cooling tower. So the one currently in Kai Tak, there's one plant called the North plant, which uses cooling tower. The other plant uses, it's called the South District Cooling Plant, uses seawater cooling. Yep, so the key benefit of the district cooling is to basically save a lot more electricity, and it's approximately 20% more efficient than the conventional system. The other benefit is to leverage the economy of scale. So basically, by scaling up, we can reduce the amount of what's called the man-hour per cooling load produced. And on the other hand, we also save a lot of floor space. As I mentioned before, we have the highest cooling capacity per floor area. The other benefit of the DCS is the elimination of the heat island effect, especially in Kai Tak is a redevelopment area. So we want to sort of maximize the urban experience. So reducing that heat island effect is pretty important. Yep, and then, so most importantly, is the application of BIM on this project. And this is the first DCS project fully using BIM. So the previous two projects did not utilize BIM. Yep, and the other thing that's really special about this project is because of the high, as you can imagine, the high electricity consumption on this project, we have to house a CLP 132 substation within the same building. So we'll use all of the electric capacity from the CLP 132 substation to supply electricity for this building in order to produce the cooling load. And the other thing is, I mentioned earlier, for the North District Cooling Plant, it is using cooling tower. And then we are going to help them to switch over to use seawater, which gives a higher COP. And so in the same building, it also houses a seawater pump house for the North District Cooling Plant. And the other benefit of this project is, as you can see, adjacent to this site, there's a DSD facility, which is on top of the Kai Tak River. So basically by pumping the seawater from the Kai Tak River, we are improving the circulation and improving the water quality inside the Kai Tak River. Yep, so and on top of just building this building alone, actually we're building over like 10 kilometers of chill water and seawater pipework. And our pipework actually span across over like 10 different interface contractors. And then on top of that, we've also got substation to be built inside other sites. So our main consumer for the chill water is Kai Tak Sports Park, which is going to be the biggest sporting facility in Hong Kong, and the New Acute Hospital, which is going to be the biggest hospital in Hong Kong as well. So the challenge is, how do we interface with all these different contractors, over 10 different interface contractors? And one of the solutions is to leverage BIM. Yep, and then because all the other projects also uses BIM, so we can communicate using that common data environment, and then import our model into their model, and that's how we interface with each other. Yep, and then one of the biggest challenges is the tight building footprint. So as you know, Hong Kong is known for tight space, and so we have to fit everything, including the CLP 132 substation, including the North District Pump House, including an education center, a massive chiller plant, everything in one building with a very tight footprint. So to make that happen, there will be a lot of layers of MEP within like a same floor space. And using BIM was one of the major tools for us to design from the early design stage and to declash and to coordinate with different stakeholders. Yep, and then we also leveraged BIM for early design stage to quantity takeoff, to construction method, and as in the construction sequence. Yep, so just to go back a little bit, this is the pipe work that we are constructing. Yep. And then to show the construction sequence, we've also got MIMEP module design using the BIM. So to further illustrate the point, I'll just jump straight to a video, which will make it easier for you guys to appreciate what we have done and achieved in this project. So I'll just jump to the video. Oops, sorry.
The District Cooling System, DCS, at the Kai Tak development is a large-scale centralized and energy-efficient district air conditioning system which is also the first of its kind in Hong Kong. It uses seawater to produce chilled water at the central chiller plants and distributes the chilled water to customer buildings through an underground piping network for air conditioning use. The DCS achieves energy efficiency by leveraging economies of scale, as well as the highly efficient and reliable operation and maintenance. Compared with a traditional air-cooled air conditioning system and a water-cooled air continuing system using a cooling tower, the DCS can reduce the use of electricity.
In view of labor shortages, tight construction schedule, and limited workspace, safety hazard is of particular concern in large-scale MEP projects. Maximizing prefabrication with MIMEP is the way to go. Paul Qianhai joint venture applies an innovative construction method, DFMA MIMEP, in the construction of the additional district cooling plant. The DCS plant accommodates large E&M equipment, including 15-meter-long traveling band screen, integrated air handling unit, MIMEP modules, and large-diameter prefabricated pipe modules. They are prefabricated off-site under the concept of MIMEP, with an order of magnitude increase in quality control and safer working environment.
To achieve the MIMEP concept practically, building information modeling is an indispensable tool. JV has employed as a BIM consultant to advise on how to implement full BIM into the project. Starting from the design stage, BIM is fully applied by all stakeholders for the design, coordination, and communication, including subcontractors such as manufacturers. Manufacturers can design, plan, and produce prefabricated modules through a BIM platform to achieve a Class 3 design, effectively shortening construction time and enhancing overall work efficiency.
With the progress of the works, engineers can plan, adjust, and optimize the modules to be built with the BIM models so as to increase the accuracy of the modules for on-site installation. To estimate the installation space required for module delivery, engineers use BIM during early design stages. They simulate the delivery process, ensuring smooth transportation and assembly of prefabricated modules, while enhancing worker safety consciousness. Each module will be affixed with a QR code to record packaging details, logistics and delivery status of the module for engineers to keep track of the status of each module in cloud server. AR is used on site to overlay the BIM model onto the construction site, enabling engineers and workers to visualize complex module setups. Nowadays, CDE like Autodesk Construction Cloud is a fundamental tool used to manage BIM data, but face security challenges. The digital twin platform is applied for safety monitoring use. Carbon emission calculation is popular. To accurately calculate carbon emissions, we submit the BIM model to iBeam Unison platform. The BIM model is not only used for construction but also for asset management. To ensure accuracy, laser scanning and standard checker, developed by Dynamo, are performed to verify geometry and information respectively. This enables smooth application of BIM AM during the operation stage. With the adoption of MIMEP with BIM into the project and comparted with the traditional method, it is expected that the E&M construction period will be expedited by about 5 months and about 40% of the on-site E&M staff saved, thus effectively addressing the problem of manpower shortage.
Our team is proud to work on this EMSD project to design, build and operate a world-class district cleaning plant that supports the Qianhai development. To support and drive the digital transformation of local construction industry, we have actively taken the lead to participate in the FMA, MIMP, and BIM, through cooperating with the joint venture partners, R&D department, and academic. We remain committed to enhance our BIM technology and utilize innovative approaches to meet the evolving needs of our clients, while contributing to the sustainable development of Hong Kong.
So thank you. I hope this gives you a good overview on how we apply BIM in our project. Thanks.